Bismillahirrahmanirrahim. Sallallahu alayhi wa alihi wa sallam. Allahumma rabbi zidni ilma. Sallallahu alayhi wa alihi wa sallam. Ameen. Alhamdulillahi rabbil alameen. The topic of this lecture is polynomial equations in complex numbers. An important advice for me and for everyone: we must be soft to others. You can find the link of the math website in the description, where you can find the soft copy of this lecture. The quadratic factor. If one complex root is given, then write its conjugate first and then form the quadratic root of the given polynomial to factorize the polynomial. Let's understand this concept with the help of this example. Given z minus 2i is one complex root of this equation. Now to factorize this equation, we need its quadratic factor. So for the required quadratic factor, we need to write the conjugate of this complex number. And the conjugate of this complex number is z plus 2i. Hence we have two complex roots of this equation. Now, by taking the product of these two roots, we can get the required quadratic factor, which is z square plus 4. When you will multiply these two, you will get z square and minus 2i whole square. This 2i whole square will become 4i square. As we know, I square is minus 1, therefore this entire thing will become plus 4. Hence, the required quadratic factor of p of z is z square plus 4. And this factor will be used to factorize this polynomial. Polynomial equations. There are three methods to solve polynomial equations. Number 1, long division. Number 2, synthetic division. And number 3, comparing the coefficient method. I personally prefer long division method to solve the polynomial equations. Example number 1. Show that z is equal to 4 is a root of this equation, and hence solve the equation. The first part of this question is very simple. We just need to substitute 4 into this equation and we need to prove that remainder should be 0. So to solve this first part, we have to suppose this equation as f of z. Now by substituting z is equal to 4 into this equation, we have shown that remainder is 0. Hence, z is equal to 4 is a root of this equation. The second part of this question is hence solve the equation. For that, we need to use long division method. You can use synthetic division or comparing the coefficient method if you want. So this is the linear factor of this equation. You all know how to do long division. In long division, we divide this first term by this first term. So when we will divide z cube by z, we'll get z square, and we will write this z square here. And then we multiply this z square with this factor, with this bracket. So when we will multiply z square with this z, we'll get z cube. And when we will multiply this z square with negative 4, we will get minus 4z square. Now opposite the signs of these two terms and then simplify these two terms. So these two will be cancelled, and this 3 and this plus 4 will become plus z square. Copy this negative 3z here and repeat the process. And we must get 0 here. The remainder must be 0 because this is the factor of this equation. Now we have got the quadratic factor of this equation. So this is the linear factor and this is the quadratic factor, and we need to solve this equation. Since breaking the middle term is not possible here, so we have to use quadratic formula. So when we will use quadratic formula onto this equation, we'll get this thing. This is the simplified form. Now by breaking the LCM, we'll get two complex roots, minus half plus minus root 3 upon 2i. and this is the real root. Since this is the cubic polynomial, so we must have 3 answers, and these are 3 required answers. Example number 2. Given z minus 2i is a complex root of this equation. The question is solve this equation, p of z is equal to 0. Since this is one complex root of this equation, so its conjugate must be the other root of this equation. The conjugate of this root is z plus 2i. Now we have 2 complex roots of this equation. So by taking the product of these 2 roots, we can get the quadratic factor of this equation. And this factor is required to factorize this equation. So whenever one complex root is given, always write its conjugate and then take the product of those 2 roots and then get the quadratic factor to factorize the given equation. Now by using long division, here we have this second quadratic factor. Since this is a quartic equation, an equation of order 4, so we must have 4 answers. So these are 2 answers and these are 2 answers. We have to solve this equation. When we will solve this equation, we'll get plus minus 2i, and when we will solve this equation, we'll get plus minus 3i. So these are 4 complex roots, 2 complex roots and 2 complex roots, hence 4 complex roots. I hope this lecture will help you to understand how to solve polynomial equations in complex numbers. Good luck. Allah Hafiz.